Ah, sorry. Yeah, the music might have been too loud. I can fix that by changing the desktop noise. So apologies if the music was too loud and I'm too quiet. I can fix that. Geo,
Can you hear me?
loud and clear, man.
All right, just give me a second. So yeah, again, they're parallel.
Come on then, talk me through this.
So can I share my screen?
Sure. We don't need audio, do we?
No, we don't. So you should be able to see my screen right now.
Certainly can.
All right. Are the train tracks parallel?
Yes.
Yeah, then the light rays are parallel as well.
Yeah,
Depends on the angle from where you're looking at them. That's all.
Yeah, but if you look through the clouds and the clouds are only like however many feet up, if the light source is coming through the clouds and the parallel, you could then reasonably conclude that they're parallel. But if they're only coming through the clouds from a few hundred feet and they don't appear to be parallel,
Yeah, why should they appear to be parallel? I mean, I've shown. I mean, you're here. Obviously, you're saying that the distance to the cloud matters, and the distance here in this case to the train tracks is only a few centimeters, maybe a meter or so.
yeah.
So, what's your point?
But I mean, I've got my screen on now. I know you can't see it, but
I can see it in the YouTube Hangout.
yeah, I'm having a hard time accepting that they're parallel because they don't look parallel. Why do they not look parallel when you're saying that they are parallel?
For the same reason that the train tracks don't look parallel when you're standing right on them, because you're looking at them at the very shallow angle, and you know that the angular distance between the two train tracks in different distances is dependent on the distance, right? I mean, that's literally what the law of perspective says.
Let's put it out to chat and let's just see what chat think because I'll be honest, I'm struggling being persuaded that these are parallel lines. Let's just see what chat says. If you think that the rays that are on screen now can reasonably be interpreted to be parallel, hit 1. If you think that the rays that are on screen now are reasonable to interpret that they are not parallel, hit 2. Let's just see what people think because I struggle with this being parallel because they clearly don't look parallel. Definitely not parallel. 2, 1, 1, 1, 1, 2, 1. Come on, Jared, you can't possibly think that they look parallel.
I'd say, judging from the chat, it's about 50-50. Is that fair to say?
Yeah, I'd say 50-50.
So, my suggestion is that we do a geometrical model of this entire thing. Using the same software that I used 4 or 5 days ago.
A geometric model. Are we talking perspective or are we talking geometrics? That's the issue.
It's the same thing in this case. Everything we need to do is measure the angles between the two train tracks as seen from the vantage point. That's all.
But if we're looking at the image that I've got on screen now, and the sun's not the connecting point of where all the lines converge, just above the clouds, the way it appears, if the sun's 93 million miles away, why are they not being parallel? I don't get it.
Let me just ask you something. So you see the spot where the light rays are shining through the clouds, right? The holes in the clouds.
Yeah.
And when you take a look, let's say at the one at the top left, and then you look at the spot where the light rays actually hit the ocean. What do you think is the distance between the two spots in terms of let's say you're standing at the point, you're in a boat at the point where the light hits the ocean, right? How far do you have to travel with the boat to stand directly below that hole in the clouds? And I think what you're not understanding is that there's a large difference in distance between the 2 points.
Yeah, but I can see both arguments in terms of them being parallel and not being parallel, but it really nothing tells me that these are parallel. Everything tells me that they're angled.
Yeah, I agree. They look like they're angled, but when you take a look at parallel lines elsewhere, as for example at the train tracks, or as for example as your previous guest, how was she called?
Brenda.
Whatever. What?
Brenda?
Brenda, yeah. How she said, for example, it's skyscrapers.
Yeah, but that's when you're looking down the barrel of the gun. I would agree on that instance, but we're not looking down the barrel of the gun here. We're looking objectively from the side, looking in. That must make a difference.
No, how do you know that? You can't say that the angle is different before measuring it. For example, you would have to measure the angle when you're standing at the position where the let me just get back the picture. For example, when you look when you are at the position where the sun rays hit the ocean, you have to measure the angle above the horizon, for example, of the light rays to say how big the angle is, because from this picture you can't tell it. I predict that the angle is rather small, maybe 20 degrees or so, and that's one reason why it's looking not parallel.
I'm going to ask Vinegar Strokes in chat. Vinegar, do you think that the rays are parallel, or do you think the rays are angled based on what you see? And we'll give her a minute to respond. And the other question becomes, how would we test it? I mean, I know you're saying about the geometrics, but is that the measuring stick that we should use, or is there another way?
Yeah, for example, in the picture that you have on your screen, there are 2 spots where the sun rays hit the ocean, right?
2 spots? There's about 8?
Yeah, let's go for the 2 brightest spots. The one that you can clearly see on the ocean, on the bottom left.
It looks like there's 3 on the back horizon.
Yeah, whatever. The amount is not important. What I'm saying is get 1 person each to each spot and then measure the angle towards the horizon, and I predict that they will be identical. That's the way to test it.
I'm not sure. I'd have to have a think about it, because I'm not sure that.
I mean, we can do it geometrically. That's quite easy.
The thing is, the way I see it is this: if it's perspective, it's perspective from your eyes. It's not perspective from the third person, which is what we're doing by looking at these lights. Because it's not perspective then; it's objectivity.
Can you share my screen? I'm going to make a model of it.
Yeah, I'll put your Skype back on. Hang on. Where is it? Skype. Right, we're watching your screen.
Oh.
Right, just keep your... what I'll have to do here is just...
So what I'm doing now is I just take randomly 2 positions on the x-axis. So in this axis, in this model, the x-axis is the surface, okay? So this is rather zoomed in, so I don't have to worry about a flat or a curved surface. In this case, it doesn't really matter, because the angle between them the distance between them relative to the size of the surface that it's sitting on is rather minuscule. So what we then would have to do is... No, that was not my intention. Is position. All right. Shit. All right. So let's say that this black, in this case black, horizontal line is the clouds, okay?
Sure.
I just give it a different color and make it, I don't know. Let's go for green. I hope you can see it.
Yeah.
So, under the condition that the sun is far away and that the lines are parallel, when, for example, you measure an angle, let's say, for example, that angle, on the position A, right?
Yeah.
Then, if the lines are parallel, you should also measure the same angle. In this case, 132. Give me a second. I'll just draw it on the other side. It's easier. So, right. So in this case, the angle is 46 degrees. Yeah, let's go for 47 degrees, okay? I know it's not accurate, but it's about teaching you the principles. So, in this case, if the lines are parallel, what the heck? I can do it differently.
Lottie says in chat, Geo's lost all Geo's lost all flat earthers already.
Just need a few more points.
Yeah. Harry Growler says the law of perspective is based on your perspective of what you're viewing, not a theoretical side angle bollocks. I agree with that.
No, it isn't. Perspective is all about geometry.
No, so again, it's about your perspective. It's not about an objective perspective.
So let me do this again, okay? So let's go for 315 degrees. Oh no, a minute. Yes, that was what I was trying to do. So now in this example, the angle between the surface and the light ray is 45 degrees, okay?
Yeah.
So that's one vantage point. If the lines are parallel, then from different vantage point, in this case, for example, B, we should be able to see the same angle. Would also get 45 degrees. All right? But if the lines are not parallel, meaning that the sun, in this case, would be close, for example, here, right above the clouds, then if you then take a look at the angles and you measure them again, this angle here would be, oh dear, 58 degrees. And that angle over there would be, in this example, 33 degrees. So the angles wouldn't be identical. That's quite an easy way to measure if the lines are parallel or not, or if the light rays are parallel or not.
So in that case then, whilst I accept what you say, why is it wrong to draw the straight lines over the image and show that the straight lines are not they're not parallel? Why is that wrong then?
It isn't wrong, because I would need a 3D model to show you why that's the case. But in principle, when we go back to the, where is it? To the train tracks, I'm actually going to download this. What is the wrong one? It's the same thing as if you took this photo and drew lines in there like, oh shit,
yeah, but
not like that.
But how
that? It's literally the same thing what you're doing.
Yeah, but from this perspective, this is your perspective of them train tracks, because you're looking at it the way that you're looking down it. You're looking down the barrel of the gun. But if you look side on, the train tracks are never converging at the end.
Yes, if you're not standing between the train tracks in this case, or very close at least to them, then yeah, you're right. But so that's the same thing to the clouds. If you would be standing in your picture, can you show your picture again?
That's my point. It's different. Yeah, hang on. I remember how to do this. Where is it? There. So we're not. If you were stood, can you see my cursor? Yeah.
Yes. Now I can.
I would agree with you if we're stood in this position where this light is, and we look up the column, and then everything's triangulating to one point. Then I would agree with you. But if we come out of that and we see, objectively speaking, that everything goes on the angles, then I wouldn't agree with you at that point, because we're not doing perspective at that point. We're doing objectivity. That's not perspective. It's the opposite.
We're doing perspective as well. For example, can you go back to my screen?
Yep.
Oh, no, actually, just for 30 more seconds, please stay on yours. As can you go to your spec? I can't see any screens right now. Oh yeah, all right. Let's say you're standing on your picture to the left of the two light spots.
That one?
Let's say on the left edge of the frame of the picture.
Okay.
Can you point your mouse cursor to there?
What? Whereabouts on the left?
Yeah, let's say you're standing about there.
On the bottom?
Yes, of course, on the surface. And now please share my screen. One of the two doesn't really matter. Now, if we were standing at the position that you just showed of your cursor, we would be looking at the light rays from the sides, right? And from that position, they would indeed look parallel. I mean, do these two lights look parallel now?
Yeah, but the light rays will be then, they would move around with your line of sight.
They would move around with my... No, they wouldn't. I mean, the light rays in this model are stationary. Under the condition that, first of all, the clouds aren't moving, and second of all, that you as an observer aren't moving. Then the light rays will be stationary.
Yeah, okay, I changed my position. You're right. The light rays wouldn't move with you. They would stay
All
where
right.
they are.
So if we were at the position that I just showed, you would have the holes in the clouds right there. Agreed?
Yes.
Under the conditions the light is parallel, and right there. And from that position, the light rays clearly look parallel. If that wasn't the case, if they weren't parallel at all, then from that position that we described, they also wouldn't look parallel. And the holes in the clouds would have to be at different positions.
Now that explanation makes sense, but I still prefer my own, which is that...
Why?
Because if you were stood at the bottom of those rays of light looking up, then I would agree with you that is perspective, but I don't think that you're illustrating perspective by doing this. You're illustrating objectivity of the two models that we've just discussed.
All right, let's just say that you're standing between the 2 points, okay? So we have a new point. So here's one light spot and here's another one, okay? Now, what would you see at that position?
You would see exactly what... You would see the two channels going either side of you.
Yes. And from that position, would they look parallel?
I honestly don't know.
They wouldn't. Because let's just compare this to the strain tracks. In this example, we would have the cloud layer somewhere here. So we would have two holes in the clouds, okay? We would have one hole in the clouds right there and one right there. That's what we would see. We would see from this position the hole right there and the one right there.
Yes.
They are not they're in your field of view, right? So, and right here, obviously in front of you, I mean, this isn't, the angles aren't identical, but here in this case, the distance is completely different. But we would have one light spot right there and one right there. I mean, it's tilted 90 degrees because one would be in front of you and one would be behind your back. But the principle is the same. You will still see, for example, if we had the two holes right here, we could measure the angle right here between the two. Okay?
Yeah.
So between that point, let me just... that point and that point, we would be able to see that angle right there. That would be from your vantage point in this example. So let's say that's your vantage point. That would be that angle, okay?
Yes.
So see that this angle is relatively small. But when we take a look at, for example, under the condition that we can see the light ray all the time, let's say, for example, to this position and this position, then as you can see, the angle is bigger. Do you see that?
Yeah, but if you map that out on the railway tracks to the left, then it would be the same.
No, it wouldn't, because in this example you would be looking closer. As you can see, this position is closer to you than this one, right?
Yeah.
So you would be looking this example, for example, to here and here.
Agreed. So when you did the angles would be greater.
Yeah, and then as you can see, that angle
is bigger.
Yeah, that angle's bigger, right?
Is it not the same?
Exactly. So when we compare this to this, you can see that it matches up. I mean, it's not to scale, but everything else about the geometry matches up. And that's more or less it.
So the question that now goes through my head is, you've given an alternative explanation. Which one do I accept to be true? And I honestly don't know.
Well, you can test it. You just need a good day and 2 boats. The theodolite. Two theodolites, to be precise, but whatever. It's not that hard to do.
No, I accept that it's not that hard to do. The issue that I still come back to is, are we looking at perspective when we are not looking down the tunnel? Like, if we go back to this.
I mean, perspective...
we're not looking at perspective when we're looking across.
I mean, you're always somewhat looking at perspective, because this perspective, per definition, is just the way you see things from a given standpoint, right? That's all perspective says.
Yeah, but the way we see it from this position, it's telling us that these lights are not parallel. But when you're in, if you're at the bottom of here, then maybe it is parallel from your perspective then. But I don't think perspective works when you're looking across the subject matter. I think it only works when you're in the subject matter.
No, why? I mean, you said yourself that when you're standing perpendicular to the train tracks, they don't look to be not parallel. They look parallel, right? So that's the same thing.
Gio, what I'm going to say is, I've listened to what you said, and my conclusion based on your explanation is that I'm not convinced that it's true, but I'm not ruling it out either. I'm going to sit in a state of limbo called confusion, and I don't mind admitting that I'm confused by it, because it appears to me that them lines are not parallel. I've heard what you said.
All right, just one thing that comes to my mind. I have a prediction for you.
Sure.
And that is that you will see these quote-unquote non-parallel light rays only when the sun is quite close to the horizon. Because per definition, you have to have the sun quite close to be the horizon, to the horizon for this effect to occur. So I predict that during the noon, when the sun is more or less directly overhead, especially in the summer here in Europe, you won't have this effect, at least not as much as you will have during sundown.
So therefore your point is what?
My point is that if the sun were close, you would get this effect at all the times of the day, and not only shortly before sunrise or before sunset.
Yeah, but then you could argue that if the sun was close, then because it's above your head, we're not getting an angle, we're just getting it right above your head. So it does work both ways, that for me.
No, because if the sun were close and it would be directly overhead you, then somebody standing quite close to you in one direction and somebody standing quite close to you in the other direction would report different angles, right? And that would also that would happen during every hour of the day, right? As long as the sun is over the horizon.
Let me think about it. Let me get some other opinions on it based on perceptions and stuff, and I'll come back to you at a different point, because I'm not.
Sure, no problem.
My honest position is that I'm confused by it. It seems to me that perspective is when you're in the light rays rather than looking at them side on.
What you could do? Do you have access to 2 laser pointers?
Yes.
Then why don't you just recreate the entire thing in scale? You just adjust the laser pointers to be parallel, and then use a webcam or a small camera, and hold it between the 2 laser pointers and look how it looks from that position. Because you will get the same result when the angle is small relative towards the towards the light, or in this case, the laser rays, you will get the same result as I proposed. And if you hold them not parallel, you will get a different result.
Okay.
Literally, all you need to test this is 2 laser pointers and a camera.
Okay, let me reconsider my position. I'll come back to you.
All right.
Can you hear the voice change?
Voice change? No.
Oh, okay. Maybe it's not working.
Okay.
Maybe it will. Right, I'm going to play a tune.
All right. See you then. I'm going to leave.
Okay, no worries.